The given equation is a polar equation, and I would like to convert this polar equation to a rectangular equation. This one is hard. All right, so from polar to rectangular, I need to recall the blue ingredient, that is a y equals to r sine of theta, x equals to r times cosine theta. But this one, okay, r sine theta, r cosine theta, do you see that there is no number next to the theta? It's one single theta, right? What makes this problem tough is there is a 3 theta, and then we need to get rid of the 3 theta. I can only allow to have a 1 next to the theta. So how do you get rid of this? The first way to do it is we have to break this down. That's why you need to do your homework. You need practice. This is a 2 times sine. Watch. 2 theta plus theta. And then why am I need to do this? Because I want to use the sum to product formula for sine. So for sine, one angle plus another angle, that is equals to sine of the first angle, cosine second angle, and then this is a plus cosine first angle, sine second angle. And then for a sine, when you do an A minus B, so you keep the same thing. So this one remains the same, but you change that to a minus. And then this one remains the same. There are 2 formulas for cosine and then 2 formulas for tangent. You may need to use the cosine. So this is a good opportunity to just a wake up call. You may need to take a test. Then you better put that formula on your notes or something else. All right. Okay, back to the problem. This is a r equals to the 2. Okay, let's put this in a bracket. I will do a sine first angle, cosine second angle, and then plus cosine first angle, and then sine second angle. Okay, just apply the formula. And then what do you see here? I see a 2 theta. So that means we will need a double angle formula. Okay, how about we will just highlight that. So this one is a double angle formula for sine, and then I also need a double angle formula for cosine. Okay, so double angle formula. So double angle formula. I have a sine of 2 theta that is equals to 2 sine theta cosine theta, and then cosine of 2 theta that is equals to, this one I prefer to use a 1 minus 2 sine square. And then we plug in. R is equals to 2 bracket, and then we plug this in, right? Okay, let's just duplicate that. There we go. And then I have my cosine theta, and then plus cosine 2 theta. So we have that. And then we need to multiply. Don't forget that this is one quantity. We have to multiply sine of theta. Okay, anything that we can multiply? Cosine times cosine, right? Okay, then R is equals to 2 bracket 2 sine cosine square, and then plus sine minus 2 sine square theta. Not sine square, sine times sine. That is sine to the 3rd power. Okay, a 3rd power and a square. Okay, how about for the square? For this square, I will change that to 1 minus sine square theta, and then I will do a distribution. Then R is equals to 2, and then I have 2 sine times 1, and then 2 sine times sine squared. That will be a 2 sine to the 3rd, and then plus sine minus 2 sine to the 3rd. Okay, then I have a sine to the 3rd minus 2, that becomes a minus 4, and then I can add the sign as well. So 2 bracket 2 plus 1 is 3, minus 2, that is a minus 4, Okay, looks like after all this work, we have a third power. We have a third power. The third power, we need to do some work. Let's go back to the ingredients. We have in the blue, we have r times sine and r times cosine, right? So that means we are only allowed first degree, no number next to the theta, and then there is a r next to sine and cosine. Okay, to make the r next to sine and cosine, so how about this? Watch me. So this is another technique that you have to learn. I will just multiply both sides. How about by r to the third power? R to the third power, because we will have this. We will have a y equals to r sine theta, and then we raise both sides to the third power. Then we will have a y to the third equals to r third sine third. And then the r third sine third becomes a y to the third power. How's that? Okay, keep working. We are not even close to the final answer yet. R to the fourth equals to 2. That is a blue R next in front of the bracket. So that means both the 3 and the 4, they share them. Then I can do a 2 times 3. That gives me a 6. And then R to the third minus, not yet. Forgot the sign. And then minus 2 times 4. That gives me an 8. And then I have a r to the third, and then a sine third. Okay, and then this becomes a y to the third. So I have an 8, and then a y to the third. How about this one? The sign doesn't have a third. Okay, I can do this r to the fourth, and then 6. How about r squared, and then r times sine? So that will give you a y. Okay, then I have r to the fourth equals to 6r squared, and then a y minus 8y to the third. Are we almost done? No, I need x and y, not r, and I need x and y. Okay, the r is squared, the y is to the fourth. How about I will use this. Let's just use a different color. X squared plus y squared is equals to r squared, right? If I do a r squared and then square, then this x squared plus y squared, and then this will be a square. Okay, the r to the fourth, I can do a r squared times r squared, and then this one will be x plus y. This will be a x plus y, x squared plus y squared. This is a r squared, and then I square. That is equivalent to r to the fourth. And then I have a 6r squared. So 6r squared, I can do a x squared plus y squared. And then the y is a y, and then minus 8y to the third. Do I need to simplify anything? Let's just do something on the left side only. How about x squared plus y squared and then square? I have 6x squared y plus 6y to the third minus 8y to the third. And then x squared plus y squared squared, that is 6x squared y minus 2y to the third. 6 minus 8 is minus 2. And then this is my rectangular equation. All right. And that is the end of this problem. This is a great problem for practice. Look, we went through a long journey to get into this. Maybe this is a good place for you to take a screenshot. We just went through a long journey to get to this rectangular equation. All right, so that is the end of this video. And then the next video, let's do another problem that is also given a polar equation, and then I'm asking for a rectangular equation. All right, I will see you in that video.